standard. So I'm going to pivot from how it works and how it networks your network and makes your life easier to a little bit about cybersecurity now. There's two main standards that we see here in the United States and other parts of the world, 62443 from ISA and NERC CIP. NERC CIP is really a US-based energy set of rules. And there's some new ones coming out of Europe soon that we're watching as well. But essentially, we as a vendor cannot say that we're compliant with these, but we help our customers become compliant with these rules. And so our microsegmentation on 62443, if you see zones and conduits, on NERC CIP, it's the electronic safety perimeter. We exceed both of those standards with our microsegmentation solution. Network visibility that we provide by everything that talks through an SDN is visible, allows for all of the change control and also change tracking. All modifications are in the network are logged for us, and that helps us with all of the change tracking and auditing that is required within those two security standards. In fact, we've got some export utilities built into the software that make it a lot easier to put into some of the software tools that companies have created to help manage these audit regulations in these tools. So how do we stop these attacks? And we'll just talk about how microsegmentation helps with this. But most common attacks that are out there, and this is certainly not an exhaustive list of all the attack vectors, but phishing attacks. Everybody has gotten phishing emails. Try to get password access to one system inside of the network. And then from there, land and expand. Take an attack and go from the north, business system down to the south in the OT network. Thumb drives. This is really not like what happened with in Iran with the nuclear centrifuges, and they dropped a bunch of thumb drives in the parking lot that got picked up. No, this is, I've got an infected laptop and I'm moving a file from it to the SCADA system, and a virus just happens to come along for the ride. Misconfigured firewalls. This is so common. You throw an any rule in there. Production goes down. I can't figure out why the network's not working. Let's lower the amount of rules within the firewall to make it happen if that's where we are. And that's really problematic. Static public ports. If somebody, actually probably the biggest group that is guilty of this are OEMs. They have a machine, they want access to it so they can do maintenance. They throw a cellular modem on there and now there's access. And but there's a lot of places like that where that happens. And so that's really problematic. So proper rule creation within our software stops attacks from spreading. And that's an important thing to remember. You can make your network completely open within our software, but if you lock it down, an infected computer in finance on the left there can't even see the OT network. But when it tries to see the OT network, that gets logged. It's put in our audit logs, and then we have an API that if you have software or an SOC or something like that that needs access to that information, it's accessible. If you have on the right side a SCADA system that gets infected, it might be able to talk to the PLC because that's allowed, but it won't be able to talk to other machines in the network if the rules are set up properly. But its attempts to do that conversation will get logged, and then it can be reported northbound through the API. So let us swap over. How am I doing time-wise, Carly? I got 15 minutes to the software, and just bear with me one moment. Come on. There it is. So here's the software. This is a simulated network. I'm gonna start up by saying that. It's a ring. These are simulated switches, simulated devices. So I have got ping traffic that is occurring throughout here in order to generate some. And I actually was not generating as much during the talk because I wasn't switching back and forth. But I can see all the devices that are attempting to talk on this network. I have a dashboard that shows me, what sort of bandwidth is being used. Let's see if I can kick that up while we're talking. I have the ability to look at what devices are communicating on what protocols. I can see which rules are using the most bandwidth. I can see what the most recent events are in the history. A lot of these are port changes because I booted it up about 40 minutes ago. Even if there's more traffic, I can even see which switches have the most traffic going through them. So there's a lot of information. This topology page gives you a lot of information. If I want to see, how these two devices are connected right now, ICMP is allowed between them, and it is actually seeing 980 bytes recently of the data. If I want to look at this switch, I can see information of, okay, what peers are there? Oh, there's 10 and 30. I can see that. I know what port they're plugged into. This is, like I said, a simulated one. Otherwise, you'd see what the line speed is. I can see what devices are connected to this switch and what port. So this is your up-to-date network drawing. Everything talking through an SDN switch, everything plugged into an SDN switch is visible in this drawing. And so you have so much power and information at your fingertips here of things you can do. I'm only going to touch on this, but I'm going to put a little plug in. We've got a YouTube channel. Just go look at Veracity Industrial Networks, and we've got a set of quick tips. And those quick tips go through a lot more detail than I'm going to today on the various pieces of this software and various things. If you do nothing else, watch the first two videos. It's like 12 minutes total of your time. Completely worth it, because we could set up much better demos on those than it is easy to do in a thing like this. Setting up rules is very easy. If I want, okay, this is a beverage line. So we've got a depalletizer HMI and we've got a depalletizer PLC that we want to speak. I don't know, let's just grab, there's Modbus between the two of them. And I want to allow it. Oh, I also could monitor. So that's like an allow, but it also logs whenever it sees anything. So for occasional traffic, you want to know when it occurs. Block simply stops it at the port and does not log it because you're explicitly blocking it. Alert blocks it at the port, but also logs it. There's various policies I can drop this into. If I want those two to talk to each other, I'm going to leave it in the default policy right now. And for advanced users, you can actually type it in, which is kind of nice. So I hit save, and then I go to review changes, and I apply it. And now I have the ability for the depalletizer section to communicate via Modbus. I can create zones. In this zone, in this example, I've got a wet zone and a packaging zone. If you've ever been to a beverage line, there's a very wet zone, and there's also where they, wrap everything up and put it together. Then I can go look at the devices, and I can see that the depalletizer, the capper, the packer are all in the packaging zone, and the filler and the pasteurizer. I know there's other devices out there, but I said as an example is in the wet zone. So we can create rules that allow entire zones to communicate if you want to do it that way. I can look at the switches. In this case, they're all open V switches within my simulator. I can see the individual ports. Oops, I need to actually select a switch first. The individual ports here on the switch and see what's connected to it, how it's communicating, all those sort of things. I can look at all the individual devices with certain protocols like SIP, which is what Ethernet IP is. We will actually go out and get more information and give you more details about the individual device. So if you've got a PLC attached to your network that's like an Allen Bradley PLC, it'll fill out more information around serial number and that type of stuff. I can lump rules into policies. And in this case, I have a couple of them. I've got one for contractors and I've got one for remote access. So if I want to give people remote access to the system, I can throw them into that. Right now it's inactive, so nobody in there is actually allowed to do anything. And then I can schedule those. So if I want to schedule a contractor to have access for a week, and this one's actually passed, but I can actually do that. So if you've got somebody you want to give access to your system for a week or two, you put them in this policy, you can actually activate it. If I want to allow remote access from midnight till 5 a.m. only, so that I don't impact my network by having other things in there, I can create schedules around that. And then there's two other things. Change sets I'm just going to talk about. Essentially, we have the ability for an approval process for rules that are created. And so if you want to create a rule and then you want to ensure that the person that creates it doesn't also approve it, you can have somebody else be an approver for that rule. And then finally, we've got a Purdue-like model. And what this does is it allows you to set up what you see as sort of the level 1, 2, 3, 4, 5. Like I said, it's Purdue-like because it's flexible. It is customizable for whatever situation you have. But say we've got a PLC here, really should only be talking to the visualization and the industrial level. So we check those, and if we have a PLC trying to talk to a VPN, we will allow you to see that, and you can decide whether or not that's something you actually want. Probably shouldn't be happening, but we allow you to audit that and see what's there. And you can throw whatever devices, and then in the devices you categorize them, or like I said, for certain protocols, we automatically do that for you. So that's what I wanted to show you in the software, and I'm just trying to be cognizant of time here also. So I'm going to switch back to the presentation and share that again really quickly here and put that back into full screen mode and go to the next one. So what we're really giving you is very consolidated network management for the OT space. This is a tool that is absolutely focused on OT, not IT. That's why when you were in there, you saw HMIs, PLCs, motor starters, remote IO, historians, that sort of a thing. Everything communicating through our switches, and not our switches, SDN switches, is visible. So you have an up-to-date network drawing at all times with very easy clickable finding of information if you're trying to debug something. It's the network topology page is very powerful. This is a micro-segmented network. It's just how it's put together. It's not added on. It's not, something that you plug in to get. It's just part of how the network is run. And so it's inherent, very robust network security, and it's a very reliable network. These issues that you have with, like I said, loopbacks, VLANs, those sort of things, go away when you use an SDN network. It's just a super powerful tool. And so I'm going to leave you with this before we open it up for any more questions. But what would you rather have running your network? That 25-year-old Ford Taurus or something really fancy and new like a Tesla? Although it's funny, I do get some pushback on the whole Tesla thing. Other people have other suggestions for what type of vehicle they would like to see in here. But really, that's the difference. I mean, 25-year-old networking technologies or something brand new and very contemporary.